Let's take a look at the exercises for chapter 5. If A and B are mutually exclusive events with probability of A 0.3, probability of B 0.5, then the probability of A or B will be equal to, since they are mutually exclusive events, and I'm looking at the probability of one or the other, the only thing I need to do is simply add the corresponding probabilities. Probability of A plus probability of B, 0.3 plus 0.5, so the correct answer will be C. If probability of A is equal to 0.68 and probability of B is equal to 0.37 and probability of A and B is equal to 0.27, then the probability of A or B will be equal to what? We simply plug in the information. Probability of A or B is equal to probability of A plus probability of B minus probability of A and B. This is the formula. Probability of A is 0.68 plus 0.37 minus 0.27, and the correct answer will be 0.78. If X and Y are mutually exclusive events with probability of X equal to 0.295 and probability of Y 0.32, then the probability of X and Y will be equal to what? Since they're mutually exclusive events, that means there is no point of intersection between the two events. The probability of both of them occurring at the same time will be 0. If A and B are mutually exclusive events, then the probability of A and B will be equal to 1. As we just mentioned, this is false. It's going to be equal to 0. If sample points A, B, C, and D are the only possible outcomes of an experiment, find the probability of D using the table below. Since these are the only possible outcomes, we know that if we add the corresponding probabilities, they will have to add up to 1. 5 over 5. So 1/5 plus 1/5 plus 1/5, 3/5. So the remaining one should be 2/5 to give us the 5/5 that we should have. So the correct answer is B. Let's look at these problems. Assume you have applied for 2 scholarships, a merit scholarship and athletic scholarship. The probability that you receive the athletic scholarship, P of A, is equal to 0.25. The probability that you receive both, P of A and M, is equal to 0.1. The probability of getting at least 1, that means probability of A or M, is equal to 0.3. This is what we are given. I'm looking for the probability that we will receive a merit scholarship. So I'm looking for the probability of M. This is what we have. We will go to our formula when we're looking for probability of M or A, where this will be equal to the probability of M plus the probability of A minus the probability of M and A. We have 3 out of the 4 formulas. We have 3 out of the 4 probabilities in our formula. So we will basically solve for the unknown. So we have one or the other, 0.3, is equal to the unknown plus probability of A, 0.25, minus 0.1. And from that, if we solve for the probability of receiving a merit scholarship, we will find that the probability of M will be equal to 0.15. Now, the probability of an economic decline in 2020 is 0.3. the probability of 0.7 that there is a probability of 0.7 that we will elect a Democrat president in 2020. The probability of an economic decline or to elect a Democrat president in 2020 is 0.8. What is the probability of a Democrat president and economic decline in 2020? So what information do we have? Probability of selecting a Democrat, 0.7. Probability of having an economic decline, 0.3. Probability of one or the other, 0.8. And I'm looking for both. It always helps when you write down what probabilities you have and what you are missing. Again, we will use the same formula. Probability of D or E is equal to the probability of D plus probability of E minus probability of D and E. Plug in the information that you have. This is 0.8, 0.7 plus 0.3 minus the unknown, and you solve for the unknown. If we solve for the unknown, we will find that the probability of both occurring will be equal to 0.2. As a company manager from Clemstad Corporation, there is a 0.4 probability that you will be promoted this year. There is also a 0.72 probability that you will get a promotion or a raise. The probability of getting a promotion and a raise is 0.25. What is the probability to get a raise? So, what do we have? Probability to get promoted is 0.4. Probability of getting promoted or getting a raise is 0.72. The probability of getting promoted and a raise is 0.25, and I'm looking for the probability of getting a raise. Once again, we use the same formula. Probability of P or R is equal to the probability of P plus the probability of R minus the probability of P and R. So based on what we have, 0.72 is 0.4 plus the unknown minus 0.25, and from here the probability of getting a raise will be equal to 0.57. Problem number 4. A bank has the following data on gender and marital status of 200 customers. So we know that the grand total will be 200. So we calculate all the totals, 120, 80, 50, and 150. I'm looking for the probability of selecting a male or single. A male or single. These two events are not mutually exclusive. That means they can occur at the same time. That means we will take the probability of selecting a male, which is 120 over 200, plus the probability of selecting a single, which is 50 over 200, minus male single, point of intersection. So 20 over 200, and this will give me 150 over 200, which is 0.75, a very high probability. What is the probability of finding a single female? Both single female, point of intersection 30 over 200, 0.15. What is the probability of finding a married male customer? Married male, that means both. Married male, point of intersection 100 over 200, 0.5. a card is drawn from a standard deck of 52 playing cards. Find the probability that the card is a 10 or heart. These two events are not mutually exclusive. You can have a card with both characteristics. So this will be equal to the probability of selecting a 10 plus the probability of selecting a heart minus the probability of selecting a 10 and heart. The probability of selecting a 10 is 4 out of the possible 52 cards. A heart is 13. We have 13 cards in a deck of cards. And how many cards have both characteristics? This would be only 1. So the probability will be 16 out of 52.308. Find the probability that the card is a 7 or queen. 7 or queen. Once again, they are not, actually in this case, they are mutually exclusive events. That means you cannot have a card that is both 7 and a queen. So we simply add the corresponding probabilities. The probability of getting a 7 is 4 out of 52. The probability of getting a queen is also 4 out of 52. So 8 out of 52 for the probability, 0.154. In case you cannot see it very well. Find the probability that the card is red or diamond. Now, red or diamond, since all diamonds are red, you're basically gonna do the probability of selecting a red, which is 26 out of 52, plus the probability of selecting diamonds, we have 13 diamonds, minus the probability of selecting red and diamond, all of them are red, therefore we subtract all of them. This goes away, so your probability will be 26 out of 52.5. And this concludes the problems for chapter